Alrighty, everybody, we just got it okay to start our final planetarium show of the day. So I'm going to be putting away our space trivia questions for now because now we're going to be heading into the unknown. Ooh. And welcome everyone to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter for this afternoon. And just a heads up, I'm not a voice coming out of the walls. I'm a person and I'm standing right behind you. Hey, what's up, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. Everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below that purple globe. And folks, I'm very happy to announce that the show that we're going to do today, right now, is different from all the other ones that we've done here in the Morrison. This one is called Tour of the Universe. And this show is completely live, so you're going to hear my voice for the next 30 minutes. And what this show entails, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things. But before we get started with our show, folks, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time. There's a few of us in here right now. First off, there's no food or drinks allowed in. If you manage to bring in any snacks, make sure those are put away till the end. We want to keep the theater as clean as possible. We greatly appreciate your help. Also, if you got any cell phones, anything that produces really bright white light or loud sound, now's the time to put it away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show experience. And folks, if you need to leave at any point during the show, the exits are always going to be at the top of the planetarium, so always make your way up the stairs to exit. If you have trouble climbing the stairs, don't worry, we understand. Just remain seated. Once the show's over, we'll have someone escort you to a lower exit once the show's done. And last but not least, folks, at any point during the show, if you start to feel overwhelmed, you start to experience motion sensitivity due to our 75-foot dome above us, there's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, folks, it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the Earth. We can see the city lights just down below, but we're starting off at this spacecraft in front of us called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is the ISS? I always hear about it in the news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct all different types of experiments up here. They'll conduct things like what happens when you try to grow plants in space. Do the plants grow the same? Do they grow differently with less gravity? Which way do the roots grow? Another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After the year, they compare and contrast the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long period of time, remember to exercise daily. And folks, the International Space Station looks really big here in our planetarium dome, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, don't worry, you can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And what's really impressive is that this thing is going really fast. The International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And this also looks really far away from our planet, but it's not that far either. It's only about 225 miles above the surface of our world. 225 miles for us Californians, that's not too far away. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans out into space nowadays, only 225 miles above the surface of our world. The reason why? Well, it's very expensive to travel into space. You got to build yourself a rocket ship or buy yourself one, and then you have to account for a lot of rocket fuel. You're going to need so much rocket fuel, you got to be able to escape the Earth's gravity. And once you do that, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space, so the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop in our tour of the universe, so now we're going to see it slowly disappear to the city lights down below. In fact, before we lose track of it, I want to add a nice little orbital path so you can keep track of it as we slowly see it disappear. And as we start to zoom on out, folks, you're now going to realize we are flying just above India. Hey, look at that. And now we're able to see our entire planet Earth. And folks, I want to let you know that the space program that I'm using in here in the Morrison Planetarium is something that you can go home and you can fly through space just like how I'm doing. The space program that I'm using is called OpenSpace Project. So this is an open source software, so anybody can add to it, and it's a whole lot of fun to use. But it's in its beta phase, so we may come across a few bugs and glitches. If we see anything, I'll point it out. Hopefully we can look past it. And also, folks, OpenSpace uses a whole lot of processing power and storage information. So if you got an older computer, you may not want to download it. But if you got something new and you know computer program language, give it a try. It's a lot of fun. But if you're a person like me that doesn't want to download anything, I just never delete anything, we also have another great alternative called NASA's Eyes. So go to your favorite search engine, type in NASA's Eyes. You can fly through space without having to download anything, and it's so much fun. But what we're using in here is OpenSpace Project. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. Alrighty, folks, we are making our way to the moon, and we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission called Artemis. Pretty much, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we got to figure out exactly how we're going to be able to live out here in space. So the moon is the perfect stepping stone to figuring out how we're going to be doing that. And what's really cool is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to do a lot more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon, because we found ice there. And ice is going to be very helpful because we can melt that ice, pass electricity through it, separate the hydrogen and the oxygen. Both of that stuff is very valuable when you're way out here in space. So look out for any news about Artemis in the coming years. We humans should be heading back to the moon relatively soon. And folks, when we look at the moon here on Earth, sometimes it feels like the moon is incredibly close to us. It feels like you can reach out your arms and touch it, especially when it's close to the horizon. But the moon is incredibly far away. It's about 240,000 miles away from our planet. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it, and if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. Now, light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so ever since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to see the moon and the Earth in its orbit as they start to slowly fade away. In fact, before we lose track of it, I want to add some nice planet trails because, again, space is really big. You can easily lose stuff out here. So there goes our moon orbit. There goes the Earth's orbit coming into view right now. And on our journey, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models helping us show the most accurate images and information available to us, like OpenSpace project. And now the nearest star to us, the sun, comes into view. So here comes the sun. Do. And also, folks, the sun is incredibly far away as well. The sun's about 93 million miles away from our planet Earth. Whew, 93 million miles. That is a good distance away. And again, we're the third rock from the sun. We got 1, 2, 3, that's us. 93 million miles between us. In order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes to cross the 93 million miles. And this is a really cool concept to keep in mind, because let's say the sun was to turn off all of a sudden, that last bit of sunshine would be emitted. It would travel that 93 million miles, that 8.5 minutes, and then all of a sudden, the daytime on Earth would become nighttime. And again, this is such a cool concept to keep in mind because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's kind of like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye perspective of our solar system, let's do a quick refresher of what we got here. Right in the middle of our solar system, we have our star, the sun. Closest planet to the sun, we have Mercury. Then we have Venus right over here. And then Earth, that's us. That's where we live. And then past Earth, we have Mars, the red planet. And then past the orbit of Mars, we have this really cool thing called the main asteroid belts. And this is what it would look like if I highlight all the asteroids. There is a lot of them. Then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the largest of them all, Saturn, famous for its rings, and of course we got the icy gas giants. We got Uranus, the funny one, and Neptune. And of course we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the dwarf planet, Pluto, right over there at the very top of our screen. A lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper belts. And you're probably wondering, what's the Kuiper belt? I've never heard of that before. Well, folks, this is the Kuiper belt. So the Kuiper belt is essentially a second asteroid belt past the orbit of Neptune. And what you're mostly going to find out here are icy asteroids and short period comets, comets that don't stray too far away from the sun. And we kind of came across this in 2006 because our technology and telescopes improved greatly, and so we're able to see a much smaller objects much further away. And that's the really cool thing about science, because as our technology gets better, we're able to see objects much further away, and we're able to redefine things. In 2006, we found more than 400 objects out here, and most of those objects were bigger than Pluto. So we couldn't call all that stuff planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly needed to be considered a planet. And they came up with 3 different criterias, and that was the day Pluto went from being a planet to a dwarf planet. But I want to put away the Kuiper belt because that's just a whole lot to look at. And now I'm going to be adding the many different spacecrafts we sent out in the 1970s to explore our solar system. On screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. And the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. All of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours. Not too bad either. But folks, it's time for us to leave our planetary scale behind because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And it looks like Alpha Centauri is going to be the star on the left-hand side of our screen. We can see it moving. Again, we're right in the middle. And again, 4 years at the speed of light just to reach the next star system to us, folks. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Folks, if you're to get in a spaceship today, made your way over to Alpha Centauri, it's going to take you about 8,500 years to make that journey. Whew, I don't think I could live that long. But let's stop and consider whether humanity has made its presence known because now we're going to be stepping inside something called the radiosphere. And again, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted or rather leaked into space, and it extends about 90 light years in all directions. This first began in the early 1930s with strong radio waves, early television, radar signals, and then layered the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, folks, I'm going to be adding some many markers onto the screen. These markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 exoplanets just in the nearby vicinity to us, 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, if we swing our perspective around, and if you look to the right side of the screen, you can see that we point our space telescopes in just this direction of the night sky, and we found a whole heap of exoplanets. So again, as it continues to scan more and more, we're going to be finding exoplanets left and right. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we can't answer that question quite yet. Pretty much new space telescopes are being developed at the moment. So they're on the drawing boards, they got to get constructed, launched into space. So we've got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in this star system on the far left of our screen. We find an alien civilization on the other side on the right, let's say here. We shoot them a text message. We say, hey, we're humans. We live here. Takes 60 years to get to them. They listen in, answer back another 60 years to get their message. Folks, that is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. And of course, folks, planetary systems beyond the radiosphere more than 90 light years away have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to be putting away our exoplanet markers away, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. So keep your eyes on that radiosphere. And folks, we're now looking down at our Milky Way galaxy, and I've got to ask, can anybody see their house from here? Just kidding. We're way too far away. And folks, our Milky Way galaxy is so huge, if you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. This thing is huge. And our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is an indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And real quick, I want to show you what our galaxy looks like from the side. You're going to notice our galaxy is a big flat pancake. It's really flat. And this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the plane of our Milky Way galaxy, which has planets, stars, gas, debris. So again, we like to point our telescopes galactically north and south. That's going to come important in just a little bit. And folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda galaxy. Only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or voids in space. So we can see a nice galaxy cluster right in the front of our screen here, some over here on the bottom right. We can see very few galaxies toward the top of our planetarium dome or voids. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far out now that this picture that we're looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing researcher by the name of Dr. Brent Tolley, who compiled this amazing representation thanks to the work of dozens of other astronomers working beside him over decades of time. So big shout out to Dr. Brent Tolley. But now we have automated systems that are mapping even the most distant galaxies. So now, folks, we're about to see the very large-scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And just a heads up, the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of our Milky Way? Well, if we line up our Milky Way galaxy, it would line up just like so, up and down the middle. And again, we like to point our galaxies, or point our telescopes galactically north and galactically south. But astronomers still want to make sure that there was galaxies through the plane of our Milky Way, so we have this nice purple survey of galaxies. You'll notice that we're still able to find them, but just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet, so it's just a matter of time. And unfortunately, folks, we're running close at a time on our tour of the universe. 30 minutes is just not enough time. So let's continue pressing on, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be represented by nice orange dots on either side of the large-scale structure of the universe. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks, here we are at the edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. All evidence indicates the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. And this picture is a very, very baby version of the universe. only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny differences eventually gave rise to the large-scale structure of the universe that we saw moments ago. That clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back home towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. And let's make our return trip back to planet Earth, everybody. Alrighty, folks, we're across an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. And we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reach of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everybody, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to peer through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way galaxy. We're heading straight for that radiosphere. We're making our way to our neighborhood, our star system, our solar system. And now, folks, we're about to pass the spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt region, making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history, all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound, just in time for dinner time. And I hope y'all had a great time. Thanks for stopping by, everybody. Have a great night.